Manuel Arias will present us AI tools for remote sensing of drifting matter on ocean surface, technological challenges, and range of applications. So please.
Yeah, thank you. So as said, I'm Manuel Arias. I work in the ICM, in the team of the Barcelona Expert Center. We are specialized in use of remote sensing tools for environmental and climate applications mainly. And my presentation is going to be focused in a lines of research that we are working. Obviously, this is an invitation for everybody here to decide whether we have a chance to collaborate in those topics, which, by the way, we will be very happy to do so because I'm not a mathematician, I'm a marine scientist. So to be honest, my knowledge of mathematics is quite limited despite of working in physics. The first thing I want to explain is why we recur to Earth observation. Earth observation is a huge opportunity for artificial intelligence, and one of the reasons is the large quantity of data multiparametric that we can obtain nowadays. Just currently, looking only to the Copernicus program of the European Union, we have access to more than 20 terabytes of acquisitions per day, and not counting with the 40 additional contributing missions. And those are mainly commercial private missions that also provide data to the same program. And we need to be aware it's probably one of the largest research programs in the world, with more than 95 billion euro investment throughout the time. So there is a huge opportunity to work with big data and applications that are trying to identify information within complex systems. One of the aspects that is more relevant nowadays is that Earth observation, it's a critical element of what we are calling the digital twins of the Earth. So probably some of you have heard of this, which is a European initiative that is trying to build this replicate model of the Earth system in order to understand better the behavior of and the evolution of different aspects, like, for instance, climate change or environmental effects. And is very well driven by artificial intelligence, actually. In fact, recently this year, the European Space Agency has released two important ITTs in this regard that are aiming to create a foundation model and a large language model to work with Earth observation datasets. So the purpose of this initiative is trying to really increase the use and the introduction of Earth observation within the society, and in particular make it much more accessible to public organizations, private entities, etc. The idea is very clear. You have these models in which basically, yes, similar to ChatGPT, you introduce your query, and then that triggers a processing chain that gives you back the level of information that you are aspiring to get. This is going to be quite big, actually, and is expected to introduce opportunities to develop a huge number of AI for EO applications, artificial intelligence for Earth observation. So in the coming years, this is going to be very, very important. We are going to explore now three topics. I'm mainly interested in environmental problems that can be tackled from remote sensing tools, and in which we can try to devise eventually techniques that could become into services with impact, direct impact into society applications. One of those is marine litter, and marine litter, probably some of you have heard of it because it has been on the news for some time now. But in a sense, the main problem that we got is that we are throwing into the ocean 8 million metric tons per year in average. Last estimates are duplicating this value to almost 16 million per year. And most of it ends up into the seafloor, but there is a significant part, around 240, 255,000 metric tons, that remains floating into the ocean. And this part is what we can see with satellites. The part that is in the seafloor is currently not accessible for Earth observation. So we try to work in how to identify this floating plastic into the ocean. And it's difficult because of despite of that most countries have particular observing networks for trying to monitor this type of environmental problems. The United Nations of Environment already decided in 2016 that current methodologies are not sufficient to really report on this particular environmental problem. And actually, they recommend to use alternative automated and remote sensing technology, which is precisely what I'm trying to help. And one of the reasons why we think there are opportunities for this is because of, despite the fact that plastic is floating into the ocean in a very sparse manner, which is very difficult to detect because we can count on a few kilograms of plastic per square kilometer, so it's very difficult to see in a pixel of one image. There are events which generate huge strands of plastic litter or man-made materials that are floating at sea, and those can be observable by satellites. Actually, we did application some time ago, this one, in which we really embrace or explain the opportunities. This type of floating structures, they have lengths of some hundreds even to a few kilometers, some hundreds of meters even to a few kilometers, and they have widths between 20 to 50 meters, which are fitting within the resolution capabilities of some available sensors. So we try to focus in detecting those. The second environmental problem of interest for us is sargassum proliferation. This is a seaweed, a floating seaweed. It's specific of the Atlantic, particularly in the subtropical and tropical areas, and it's a huge problem for tropical communities. And the main reason is because this seaweed was confined to a very small region of the Atlantic, but at some point in 2011, left that space and started to propagate throughout the entire subtropical Atlantic, growing in mass quantities. And the problem with this seaweed is that as it's floating, it's dragged by currents, ends up into coastal areas, and it's very bad for tourism, damage fishing, and creates a huge economical impact into all these communities working in or living in these areas. One of the aspects that not many people know is that this seaweed, when it's putrefied, releases some toxic gases, so it's even harmful for health. And the quantities can be huge, as you can see in the image. There are already some services trying to map on this because it's very relevant for them. And this is an example of a service from the University of West Indies in Sarmes. And these guys, they are already working with some satellite images, but I want to put some attention to you on those black holes we have there, because actually this is one of the limitations that this type of tools have. Those black holes that we can see much better in this image are clouds. So when we get clouds, we don't get the data that is behind this. So one of the things we would like to do, and we are trying to develop, is use artificial intelligence tools that are able to fill those gaps by using a trained model. Okay. This is an improvement for the service because, as you can see, we are missing a lot of information in the images. And in the subtropical regions, clouds are present almost all the time. So it's a persistent problem. And the third problem that we are trying to tackle is jellyfish blooms. This is also something that is quite important from the financial point of view. Jellyfish are a particular problem for tourism, of course. Everybody knows this on beaches. But it's also a very big problem for fisheries because the jellyfish are one of the main predators of many fish larvae. So when they grow in large quantities, they can decimate entire populations of fish. And the other aspect, which is also very, very scary, is that these quantities of jellyfish can clog actually the inputs, the inlets of the cooling systems of energy plants. And this, for instance, happened a couple of times in Scotland with a nuclear power plant, that they had to do emergency shutdowns a few times due to jellyfish clogging all the entries. So there is a lot of interest from society to try to be better to predict when this is going to happen in order to reduce impact. Well, this is just one video, a small video that is showing how can that look like in some occasions, with huge quantities of jellyfish clogging entire areas. So this can be a really serious problem, and actually climate change is making it worse because of jellyfish thrive, some species thrive in warmer waters, and also because we are killing their predators, natural predators. So when we kill the predators and we give them more favorable conditions, they grow massively. There are some services working, or that, let's say, try to work in this, the same concept, but none of them has come to fruition yet. And I will explain a bit why here. But the main reasons is that there is a difficult problem to tackle because we have very little ground truth data. in order to work with to try to develop models that can really replicate or define the phenomena that we are trying to study. And because of that, the best approach that we have for this is working in proxy, which in a sense is to trying to monitor under what conditions these jellyfish blooms happen, and then trying to develop models that are much better to predict when this is going to happen. This is a very good example to use multi-parametric information, because we can gather many variables coming from Earth observation or related, which we can plug into deep learning models in order to try to do this forecast of occurrence. And in our case, we have a very good opportunity, I will explain a bit later on that, to work here in this particular problem, thanks to very good data sets of jellyfish observations from that has been elaborated by the Institute of Marine Sciences for many years, based on observations on the beaches of Catalonia. But I'm going to go a bit onto the data sets that we are using, or we try to use. We are mainly focused, at least myself, in optical data. So I work mainly with Sentinel-2 and Sentinel-3, but we have also some knowledge to work in some of the other satellites that I mentioned here. And the idea is to get these Earth observation platforms along with Siemens, the Copernicus Marine and Environmental Monitoring Service from the European Union. There is a number of products based on models, which and also other observations from other satellites, which can be very useful to get this multi-parametric space to dive into this particular problem. So one of the parameters also that Eugenia has been presenting is about wind speed from ICM-CRM. And for the different problems, we get also access to some observational data directly. For the marine litter topic, we are cooperating with a university in the Aegean Sea in Greece, which they are helping to deploy artificial targets to help to calibrate models by known ground truth with real satellite observations. And we have also, we are part of this initiative. It's led by a Catalonian company, Lobelia Earth, which they have this ocean scan database in which they are gathering many in situ observations. For Sargassum, there is a number of services already available from which we can gather a lot of the data. And for the jellyfish, we plan to use mainly the information from the ICM in cooperation with the Agencia Catalana del Agua. In terms of what we do, and this is also important, we try to get physical informed solutions. There is no much point in just doing the black box system, throwing data in. We don't learn anything about that, and we really want to get more learning about how to do these things. And actually what we have found out is that the best chances for this type of applications is to combine spectral information that can give you an idea of what is your how you should observe this, let's say, in a traditional manner, and combine it with the capabilities of AI. In this particular case is for detection of floating litter rafts. This is an example of a Sentinel-2 multispectral image in which we develop this index that is able to detect this type of structures. Now, what we use is artificial intelligence to precisely do this spatial, spectral, altogether classification process to really catalog all these type of guys in systematic data sets. So we process already for this more than 700,000 Sentinel-2 images over the Mediterranean Sea, and we found really old, more than 14,000 structures of this type. For the Sargassum, we have also similar methodologies already available in the literature. These are not ours. This is existing for some time now. But what we want to focus, as I said before, is in trying to fill a method. Probably we will recur to convolutional generative adversarial neural networks to trying to fill those gaps in those images by using a label data set. The one aspect also we want to work, because it's very relevant, is in data fusion, and in particular in super resolution. This is challenging in the sense that we have many available publications that are explaining how to do super resolutions, but most of them are not practical from an operational point of view. So they work in very particular cases, but if you really want to develop some automatic tools for doing data analysis over a large area, large periods of times, they are not viable. So we are trying to focus in this idea of single image fusion-based super resolution. That in principle, what we try to do is to get information from the same images of the satellite, which you have multiple channels or bands, and trying to improve the resolution of the critical bands by extrapolating information from some of the bands to the others. We are doing this using a singular exponent data fusion at this stage. We have one of our members of our team, Antonio Turiel, is very expert in this type of techniques. And we are trying to develop this type of solutions to try to do this type of improvement. But it is true that it's one of the areas in which more development will be very welcome, not just for our particular case study, but generally speaking, it's a very important task for remote sensing nowadays. The idea why is this important is because of many public available information that is for free, has a much lower resolution than commercial datasets, and getting ways to improve artificially that spatial resolution opens capabilities to do particular studies that otherwise will be not accessible, or you should go for commercial data, which is very expensive. In terms of the areas of tools that we are more interested on currently, we are working in probabilistic classifications models based in extreme gradient boosting. This is particularly useful for the milliliter case because of the challenge we have within the milliliter is the classification of the pixels and trying to confirm what we have in each of the pixels within the image and separate it from false detections, which also happen. And this is quite complex due to the limitations of the spectral data we have. So this type of tools, we already have done some effort in the extreme gradient boosting, and they prove to have a quite good fit for separating these false detections from the true detections and simplify a lot the problem of post-processing that we have. For the aspect related to the jellyfish, what we are aiming to is to introduce deep learning models which are combining graph neural networks along with deep learning. And the main reason why we aim to do this is because the sparsity of the data. So because we have data that is quite sparse, it's much more interesting for us to work in models that are able to explain the behavior of the jellyfish based on the environmental parameters, of which we do have much more data to work with. And as I said, for the sargassum problems, we aim to work with the generative adversarial neural network models to precisely fill those gaps. And this is just some examples of these cases, as I said. Particularly interesting is the convolutional generative adversarial neural networks. This is a case applied to total electron content into the ionosphere, which is a very important parameter for some systems, particularly GPS, for instance, and you need to correct for the content. And this is an example of a paper in which they use the type of techniques we aim to do to precisely fill those gaps existing into the maps. And this is the structure of the model based in graphos that we want to implement, and actually we are already implementing on it. And this one is just a generic structure of the extreme gradient boosting, which we already also implemented. Said on that, I want to thank you for your attention, and if you have any question or anybody wants to discuss more in detail, I'm here all the day, so feel free to chat with me whenever you want.
So it's the moment of questions, short and large. Let's see.
Thank you. I have perhaps a silly question. You have mentioned that jellyfish or jellyfish blooms are increased due to climate change. But I don't know, because it seems that jellyfish is increasing a lot in the last years, and I don't know if this can be explained just by the increase in the temperature of the sea, or there is some other nonlinear factors, or there are other factors that contribute? Can you elaborate a bit?
Sure. There are, obviously, it's not just one single element. As usual, we tend to do an oversimplification of nature, but the reality is that nature is complex and there are networks of connections. Climate change impacts in two meaningful ways. One direct, another is indirect. One is about temperature, because of the temperature is very relevant for the reproduction processes of this type of species. Not all of them, as I said. Some of them are more in warmer waters, others are cold waters, and they cannot live in warmer waters. But impacts into the velocity in which they can reproduce, because they are how to say this, temperature accelerates metabolisms of organisms that are not controlling their own temperature. Okay. But the second aspect, which is indirect, is oxygen dissolution, and the increase in temperature reduces oxygen dissolved into the water column, and these organisms are doing much better in those conditions than competitors. So one of the causes that it is improving or is causing to rise the number of jellyfish is precisely this depletion of oxygen in the upper layers of the ocean due to the heating. And the third thing, which is the main one, is what I said before also, is that we are killing their natural predators. So by decimating the predators, we are allowing these species to grow with no control from the environment. And this is very important because of some species of fish, some species of crustaceans that we eat, or sometimes some reptiles like sea turtles are very relevant to control populations of these organisms, but because we are killing them, they no longer are controlled. It's the same problem with some animals here in Colserola, right? If you ask me, I will say that the extraction of the predators is more relevant.
And there's, just adding to your answer, there is also that fact that the people have the appreciation of the jellyfish when they see them on the beach. And this has a lot to do with the water masses at the coast, whether they are more or less impacted by the coast. So when there is a lot of rain and the year is very rainy, then there is the interface between the coastal and the open ocean water is farther away from the coast, and then you don't see them in the beach that much.
Yes.
So that's another.
Yes.
So the appreciation of the public is that what they see at the beach, but that doesn't really have to do with the growth of the organisms offshore, which is.
Yes, and another aspect now that you mentioned is also primary production in the oceans, which is also increasing. So probably you saw this paper this year about that the oceans are becoming greener, and this is happening because of productivity of the ocean is increasing due to mainly contamination. So we are polluting the ocean with nutrients, and this is in some ways increasing the biological production, which also gives more food to many species of jellyfish that are actually eating this plankton that is floating in the ocean.
More questions? I have one.
Yep.
You said you are interested perhaps in controlling early warning signals.
Mm-hmm.
Which kind of these early warning signals and which type of?
Yeah, so we go back to the question of the controlling factors, right? So if probably here it could be easy because this is one of the models that some people have been working on, but as I said, this has not come to fruition, but it's a good idea of how this works. Eventually, what you want to do really is to get a model that is able to learn what are the relationships between the different environmental parameters and in this case, your jellyfish, okay? And then you can use this information to forecast into the future. So, for instance, some of the data set that we plan to use from the Copernicus Marine Environmental Monitoring Service are providing forecasts. So what we can do is once we have the trained model, we can use the forecast information to really anticipate what is going to happen. And nevertheless, also you can try to get an earlier prediction based directly also in observational data, because once your model is able to start to learn what is the dynamics that relates to the outbreaks, you can design exactly, yes, an estimation of what is the probability that in 5 days or in 10 days I will have an outbreak. And then you put a threshold for your early warning based on that, and then you can do an early warning of it's likely this is going to happen, so could be good to do something about it. Yeah.
Okay, thank you.
You're welcome.
More questions? Ideas?
Well, thank you very much for this talk. I think it's a great work. I'm just curious about the possibility. I mean, you are detecting marine litter.
Mm-hmm.
So is it possible to use these kind of approaches to detect also vessels? I mean, for example, fishing vessels?
Yes.
Let's see.
Yes, but and actually there are, I think 2 months ago or something like this, there was an invitation to tender from the European Space Agency to precisely do that, with the support of synthetic aperture radar, which is much better for this task. SAR, it produces very well identifiable signals when goes to vessels, and has a Sentinel-1 has a resolution of 5 to 10 meters. So it's enough to really detect that a vessel is present in some point. So the strategy that they are following with this is essentially trying to do detections in the SAR images, and there are proposals to use artificial intelligence for this, and crossing the information with the IRS, which in a sense is giving the locations of the ships according on time, in which case you can actually see this ship in this image is actually this ship, okay? This so far is not much information, but what it is interesting is that for illegal fishing, quite often these ships, they are traveling to some point, and then they stop emitting and they appear in other points later, yeah, right? So what you can use is this type of operations to understand, okay, I got a fish here, now I don't have it, but I see a boat, and so, and the purpose of this project is trying to precisely devise methods in which we can monitor these guys doing nasty things. Yeah, yeah. Nice. But it's one of the more interesting applications, and also for maritime monitoring. And obviously not our task, but military are obviously very interested also in that type of things. Yes.
Thanks.
More questions? And about computational time, how many time lasts your calculation, and even for Eugenia?
To be honest, it depends. What we did for marine litter, I'm going to recover, sorry, is here where it is. Yeah, here. So for the extreme gradient boosting, it's quite quick. I mean, we have, as I said, we did a detection of more than 700,000 candidates, of which we manually label all of them, and we got 14,000, almost 15,000 targets that we were really looking for. Okay, so it was a bit the needle in the haystack. Yeah, that's why we wanted to develop the extreme gradient boosting, so we didn't have to do that anymore. So using this manually labeled data, we managed to get a database of millions of pixels, which I think it was roughly 30 million pixels, something like this, and of which we divided then in training and test data sets, and use this for the training. And it took, don't know, 10 hours to train, something like this. I did it with my laptop over there. So it was not no big deal. And the ones that are more difficult are these ones, the convolutional generative adversarial neural networks. First, because of you really need to do a lot of initial cataloging on all these patches of images for do the training, which are much bigger than individual pixels. And secondly, because of the modeling itself is far more complex and is far more demanding for computational services. That we have not yet started to run it. So I don't know how long will take, but I'm estimating that it will take probably several days. Yeah.
Well, I'm training one of the models right now, so it's like 2 months of data reduced to 10%. It's about 1 day and a half. For training, for inference, like 2 months, 3 months, it's about 24 hours as well.
So in that order, yeah.
I might also have a question. Do you have past data or past information of unexpected increases in jellyfish in the coast or also for sargassum? Or is it something like that has happened now and didn't happen before, like in the past?
For sargassum is very well known. The date is exactly the one that I put here is 2000. Yeah, this year. This is the year in which this started to happen. Until that moment, the sargassum was confined to the Sea of Sargassum. That's why the name, and which is one area in the subtropical Atlantic close to America. Okay. And actually, the Sea of Sargassum is very interesting for other species, including some freshwater species here in Spain, because they reproduce there, or they did. Now it's not so clear. And this, yes, started to be a problem from this. But the main cause for this is that for some reason left the area in which was confined. And this is unknown why, which is quite interesting. There is some suspicion that could be related to change in the wind circulation. So it's something that maybe we could look at, because it's an open question. Why sargassum left this region of the ocean is unknown. But right now is impacting tropical areas, the Caribbean Sea and equatorial regions of Africa, etc., are very impacted by this problem. And it's very serious for these people. You think that you go to on holidays to one of those places, and when you arrive, you find this. You don't go back, yeah. So and people talk each other. So tourism in some communities is just dropping massively, and they entirely depend on that. So it's a big problem.
They have similar problem in the Canaries.
Yeah. Yeah.
More questions, comments?
If you know that these events are coming, what can you do to prevent?
Yeah, well, that's a good question, because it's very difficult to do anything about that. What some authorities are trying to do is to be more in the prevention. Let's say this way. By preventing is not meaning preventing this, because it's very difficult to avoid this huge mass of floating seaweed surrounding to the coast. I mean, then you can see some things they are putting into boats, but it's like doing nothing. Yeah? But they try. But the main reason why they wanted to know, and especially the early warnings, is precisely because at least they can tell to the businesses that are working in there, okay, you are going to have problems this season. Maybe you should be careful with your clients and let them know maybe not to come, or trying to avoid, let's say, the bad experience. For local fishermen, it's also relevant to know where these accumulations are happening, because it's not just only that they are killing fish, which they do, but also it's because this gets entangled in all the fishing nets and that they use, so they can lose gear, which is very costly. So in that sense, they are very thankful to have information that can help them to avoid areas in which this is happening at a given moment, so they don't go fishing there. But it's very hard to do anything about this. To be honest, I don't know how they are going to, or how this can be solved, because I think this is one of those problems that has come to remain with us. It's not gonna be corrected back. That's my point of view, at least. Because, I mean, these strands have some kilometers long, and there are like thousands and thousands of tons of this seaweed floating. So, I mean, it's not gonna disappear. These images that I put here, maybe it's not very easy to see, but you see these strands, okay? Those pixels are 300 meters, so you can imagine the size of the accumulations. Yeah, some of the accumulations are larger than the islands in itself. So it's I don't think we can fix this, to be honest. But the communities want information, I understand. So we try to, we think we can help them to get better information, maybe do something at some point. But here is just mitigation, I think. You cannot do anything else.
Well, the origin probably, it's a typical example of something that's happening in the islands, but it comes from somewhere else.
Yeah, sure.
So it's for the people that are suffering the problem. I mean, they cannot do anything to prevent it because it's somewhere else where it should be done to prevent it.
Yeah.
And avoid deforestation in the tropical forest and so on.
Yeah.
So those are the causes that are more nutrients in the tropical ocean. There is more production in the tropical ocean. There is more nutrients in the tropical ocean.
Yeah. Yeah.
I saw a presentation some weeks ago from a European project, and they were relating the proliferation of sargassum with the increases of sediments and eutrophication in the Amazon. And
for instance,
and they were trying to model the dispersion of the sargassum in the area around the Amazon and how that has dispersed. The hypothesis was that the starting of dispersal in the open Atlantic started in the Amazon.
Yes, it could be, but I don't know if I have a global mapping here. Okay, because I don't have it, but Amazon is below. Okay, the sea of Sargassum, where this seaweed was originating on, is northwards. It's over there, so it's much higher level. Is let's say it's at roughly Florida, South Carolina area in front in the Atlantic coast. So it's North Atlantic, and well, subtropical, but still, I mean, they have the northern hemisphere of the Atlantic. So I think there are two different things. One is why sargassum left the area which was confined. Another why is because it's growing so much. Because this is the real problem. Here, I mean, it's funny because this is in the website, but they have this kind of indicator and the prediction in May of 2022 is that that particular summer, because it's in summer when it's worse, it will be severe problem. And actually it was. As I said, the size of the structures are massive. And sargassum is ecologically very important for many species, so it's not entirely bad. It's as usual. There are always opportunistic species that will take advantage of this, but obviously for the populations living in the areas affected is very bad.
There is an algae, I don't know if you heard, that now is proliferating in the Cadiz and in the Strait of Gibraltar.
Yes.
And every year the fishermen are reporting more and more problems.
But
in the
that's different. I don't remember the species. Maybe Pep. Yeah. But I remember it's a Japanese seaweed, and in this case, it's one of those cases of foreign species that has been transferred from the Asian Pacific coast to Atlantic coast, and has found a similar ecosystem in which can grow, but again, no predators, so it's just reproducing massively.